This is our second problem on stiffness method for truss analysis. Point to be mentioned that it is actually stiffness method, not direct stiffness method. So the first step of this math is to find out the degree of freedom. If you see that, you'll see the truss has for each joint has 2 degree of freedom. It can move laterally, it can move vertically. If you look at point A, it can move just vertically, or it can move just this way. If you look at point B, it can move both way. It can move this way, horizontally, because a ruler support has 1 degree of freedom. At point C, it has a pin joint, so there won't be any lateral or vertical movement. At point D, it can have a lateral movement. So it has three degree of freedom. Let's name them. Let's call that at point B, let's call that E1. And at point D, let's call that lateral movement E2. And at point A, let's call the vertical movement as U3. So the first step of this math is done. The second step is to form a joint loading matrix. You have for B point a load of we call the loading at point B, let's say P1, the loading at D P2, the loading at U3 where U3 is happening, let's call the loading as P3. So you can say that the P1 is 10 keep, which is going right side, so it would be positive 1. P2 would be 20 keep positive, and P3 would be uh, 10 keep, but it's downward, so it would be minus 10 keep. And if you form a matrix, the matrix for P would be something like that: 10, 20, minus 10. So the loading matrix is formed. The ultimate thing of this math is to find out the degree U1, the Doki U1, U2, and U3. And the very next step of this is to find out the bar forces. Here we have bar forces. Let's say we have a bar force of FAB, FAD, FDC, FAC, FBD. So we'll find bar forces in the very last step. Before that, we'll find out U1, U2, and U3. To find out U1, U2, and U3, we form a we form an equation. We call that stiffness equation. Let's write that. How do you write that? We have stiffness, global stiffness matrix K, and we have U, which is our displacement, or you may call that Doki, and you have joint loading. We call that P. So we have U matrix, which is U1, U2, and U3, and you have P matrix, which is 10, 20, and minus 10. But you still don't have K matrix. But what is K matrix? Your K matrix is simply like that. You have three dokis here: U1, U2, and U3. If you have three dokis, you will have a 3 by 3 matrix. So your matrix will be something like that: K11, K12, K13, K21, K22, and K23. These are the 212 or 2223 are the like positioning of the entries: K31, K32, and K33. So the thing is that you will have to find out K11, K21, K31, these things. So This column will come from the Doki E1. This column will come from the Doki of U2, and this column will come from the Doki of U3. So let's calculate things for E1. So your E1 is happening right over here at point B. So your Q1 is happening at point B. So what we'll do, we'll allow movement at point B and we'll restrain movement at A and at D. So this D point and A point will be pinned. So there will be no degrees of freedom. We'll just have degrees of freedom at point B. If there is degrees of freedom at point B and it has a displacement rightward, so it will actually bend like this. So your AB frame will be like this and your BD frame will be like this. So it will come like this and it will go like this. So if I draw this, it will be something like that. So I will draw this right over here. So you have A point right over here, and you have D point right over here, and you have BD right over here, and your cross thing. So we'll allow rotation right over here, and everything will be pinned. So there will be no movement in these things. If that is the thing, how it will move? It will move this way. If you allow movement E1, this frame will come a little bit rightward and it will connect this right over here. So you can see that your if it's a and your B would be right over here. This is C and this is your D. So you can see that your AB frame and BD frame has been displaced. So we'll find out K11, K21, K31. So how do we find out K11? For K11, it is a stiffness at the Doki U1. So we'll find out K11 from here. So for K11, the frame that is responsible is AB and BD. So we'll have AE over L of AB and AE over L of BD, because these are the frames responsible right over here. And the thing is that you have for horizontal displacement, here our Doki is horizontal. So for horizontal displacement and for that component, you have a, a value of AE over L cosine squared theta. So we'll take area of AB, which is 10. We don't know the value of E, and L for AB is 18, and we will bring cosine square theta. So what would be the theta for AB? For AB, the theta would be 0. Sorry, not 0, 90. And for BD, it has an angle with horizontal is 36.87. You may calculate the tan inverse of 18 over 24. So it would be 36.87. So for BD, you have an area of 10 E and you have a length of 24 squared plus 18 squared root over. So that would be 30. Cosine squared 36.87. 87. So you will get a value of 0.212133. So this is K11. So you will find K21. So how do you find out K21? The thing is that if you have a frame like this, and you have a displacement right over here, and you want to find out stiffness at point here, so that would be just the same value as k11, but it will be reversed negation. So that would be simply minus 0.2133. Or you may just find out this way. If you are not happy with that, you may calculate that. So there will be a negative because you have displacement here, but you want to find stiffness here, so it would be negative. Then for D point, where U2 is happening, will happen actually, but right now U2 is restrained. So for D point, you will find K21, and at D point you have a responsible frame that has undergone displacement is BD. So for BD, you have an area of 10, you don't know the value of E, and you have a length of 30, and you have and VD frame has an angle of 36.87. So it would be cosine squared 36.87. Why cosine? Because at D, we are the Doki U2 was horizontal one. So yeah, so this is the thing, and it is actually this value. So it would be just you may calculate that, but you'll get a value of 0.2133. So we'll find out K31. So how do you find that? So K31 will happen at this point. So how do you find this? If you look carefully at K31, you have a displacement at B points, not A point. So there would be a negative sign. And the responsible frame is AB. So you will bring the area of that, which is 10, and E, and the length of that, which is 18. And if you see that it's actually going the displacement that is allowed at point A is vertically, though it is restant, the dock is restant right now, but it will move vertically, so it will fall under this case. You have an horizontal displacement, which is this, but you want to find out vertical stiffness, so that would be A over L cosine theta sine theta. So you have cosine theta, but how did we the theta? If you look carefully, you'll see that for AB, the theta is 90. So it would be cosine 90, sine 90. For cosine 90, it would be 0. So K31 is 0. For the next 6 stiffness, we'll go a bit first. I just show you details math right over here. Let's say we'll find out for U2. For U2, the displacement, we'll find this matrix. We'll find this matrix. And for U3, we'll find this matrix. So how do we find out what K12, K22, and K32? So for that, what we'll do, we have uh, what may I say? We have displacement at U2, and we'll log every other joints, making that pinned. So we'll have a roller support right over here, and every other support will be pinned. So let's draw a qualitative diagram. So it would be something like that. It has a cross frame, and this frame would be pinned, but this frame would be rollered. So if it undergoes horizontal displacement, it would be like that. It is extending rightward. For that, this cross frame will go like this, and this vertical frame would be like that. So it is your A, think it was B, and it was C, and it was D. But right now it is your D point. So if you find out K12, your this point will make your this point from this point where U, this was the point of U1, this is the point of U2, this is the point of U3. So we want to find out stiffness. We'll find out stiffness at the points where we have Dokis. So we'll find out stiffness at this point, at this point, and this point, not this point, because this C point has no displacement or no degrees of freedom. So we'll find out stiffness at the point we have degrees of freedom. So we'll find out the first entry of column 2, that is K12. So where K12 is happening? K12 is happening at this point, and this point is for K22, and this point is for uh, K 12, 22, and K it is 32, because it is for row 3 and column 2. Okay, so for K12 the responsible frame is only this frame, which is BD. So you have just one frame. Since we have displacement at D, but we are finding stiffness at B, so it would be a -1. And the responsible frame is BD, that has an area of 10, and E we don't know, and the length is 30, and it has an angle of 36.87. So it would be cosine squared 36.87. Why cosine? Because the displacement that we may have at point D is horizontal one. So you'll get a value of minus 0.2133 e. Similarly, you can find out K22. So your K22 you'll find at this point. So the responsible frame is three: this frame, this frame, and this frame. Let's say we want to find out the stiffness for K22. For that, first of all, you're considering frame AD. So AD has an area of 7.5 and has a length of 24, and it has an angle of 0 degrees. So cosine square 0 would be 1. So the next frame we may have this one. So this one, for that we will get a value of 10 e over 30 cosine square 36.87. One thing you may notice that I am using plus sign because the stiffness I am getting at the point where we have our displacement, so it would be positive one. And the next frame is CD, but you can see that for CD we'll have a 10e over 24 multiplied by cosine square zeros, sorry, 90. For cosine square 90 we will get a value of 0, so I'm not considering that frame, but you may write that, but eventually you'll get a value of 0.5258. So your next thing is K32. For K32, it hasn't undergone any displacement in vertical direction, because at K32 we're considering the vertical displacement, but it has no vertical component of displacement. So K32 would be 0. So the next thing is to find out stiffness for this one. First of all, let's draw this. We will find out vertical displacement at this point. So we will allow only this one, and other support will be pinned. If that is the thing and we are allowing vertical displacement, so it will go vertically upward right over here, and this frame will be like this. And another thing will occur, that this other frame, it will be like this. So these are the things. So your A point would be right over here, and your B point would be here, C point would be here, and D point would be here. And you will find out the tree stiffness. So this is the point of K1 3. This is the point of K2 3. Sorry, this is the point of K2 3. Your K2 3 would be here, K2 3, and this is the point of K3 3. Well, let's find out K1 3. For K1 3, if you look carefully, you will find that the responsible frame is for K13 is this one, but these two frame hasn't undergone any deformation or displacement, so K13 would be 0. Next thing is K23. For K23, the displaced frame is only one, that is AD. And if you look carefully, your AD is making an angle of 0 degree with horizontal one, isn't it? And for that, let's write that. So it will be something like that: AE over L multiplied by, since it is horizontal displacement, it would be cosine squared 9. Sorry, uh, it would be something like that. Sorry, you are allowing vertical movement at A, and you are trying to find out horizontal stiffness. So for that, you will be following this one. So you have vertical displacement, which is this way, and you want to find out the horizontal component. So for that, you have an equation that is A over L cosine theta sine theta. So A over L will have something like this: sine theta cosine theta, and is for only AD. So you can see that you will have an angle of 0 degrees. So your sine 0 degree will be 0. So this frame won't have any stiffness value. So for K33, you have three responsible frame. One is this, and other one is this. So three. So let's go one by one. So your AV frame, for AV frame, you have AE over L for AV. Since you are finding vertical displacement, so for that, for the vertical component, you have an formula that is A over L sine squared theta. Since for AV, it would be sine 90 squared, isn't it? And you have an A value of, let's write the numeric value, and you have a value of 10, and you have E, and you have a length of 18. So you will get a value of, sorry, you have another two frame. Let's say we're trying to find out the stiffness for this one. So it has an area of 7.5 given, and a stiffness E, and a length of 24, and it has an angle of 0 degrees, so it would be sine squared 0. You have another frame that is this one. So it has area of 10 and a stiffness of E and a length of 30, and it has an angle. So you need an angle. So the angle, you may go this way, the angle, or you may have an angle like this. Eventually the value would be same. So let's say I'm trying to find out the acute angle one. So you have a hypotenuse, sorry, opposite arm, and you have horizontal one. It was 24 and it was 18. So immediately the value would be 36.87. So the K33 value would be 0.6756, if I'm not wrong. Well, the next thing is that you will form You will take all the values of k and you will form this equation. So let's form that equation. So that your equation would be, you have k values, k11 would be 0.2133e, and this value is 0.2133e. This would be 0. The other value is minus 0.2133e. The next value is 0.5258e. The next value is 0. This value is 0, 0. I'm just putting all the values of case 6756. And you have Dokis E1, E2, E3. And you have a load matrix that is 10, 20, and minus 10. So if you solve this equation in your calculator, you'll get a value of E1 as 142.882 over E. You'll get a value of U2 that would be 96 over E, and you'll get a value of U3 that is minus 14.8 over E. So these are the dokis that you didn't know. Right now you know that the important thing of this math is to find out the bar force. Let's say we want to find the bar force of 80. So we want to find out the bar force of 80. So how do we do that? How do we do that? If I had a little bit of space, it would be fine. Okay, let's find out the bar force of 80. The thing is pretty simple. That is, you will sorry, it is AD. So you will find the horizontal uh, uh, doki, that is at point D, we call the dx, and you will subtract the horizontal doki at point x, and you will put cosine theta. Later you will add them, you will find vertical doki at point D, and you will subtract that with vertical, it is actually ax, vertical doki at point A, and you will multiply with sine theta. The thing is that you will then multiply everything with AE over L value. Now look, the thing is that you don't have sorry, you have a doki dx at point this, which is your u2 value. So your u2 value was 96 by e, 96 by e, and you don't have any horizontal doki at point A, you have a vertical doki at point A. So you have just 96 by e, and your cosine theta, in this case your theta value is 0, so it would be cosine 0 degree. At point D, you don't have any vertical doki, you have horizontal doki, so it would be 0. And at point A, you have a vertical doki that is that is minus 14.8 over E. And it would be multiplied with, this thing would be multiplied with sine 0. And the whole thing will be multiplied with AE over L. So your A value is in this math 7.5, and you don't know the value of E, and you have a length of 24, if I'm not wrong. Yeah, 24. So your this term will be 0 because sine 0 is 0. So you will just multiply 96 by E with 7.5 into E divided by 24. So your E and E will be cancelled. You will multiply 96 with 7.5 and divide that with 24, and you will get a value of 30 kg. So this is how you just find out the bar forces. You may find any bar forces using just this formula. So this is all from this lecture.